What's up, guys? So, picking up where I left off a few days ago. Haven't worked on it in a couple days. I had other things I had to take care of. So we're gonna change directory into the main folder so that we can run the script whenever it's ready. We're gonna go to devlog. We already have it started 3/12, which is the date today. We start at 10:45. Okay, so we have our number one to do, which is finish implementing data transfer modification, and we have to finish modifications in client file. We stopped at line 645, so that's good. Okay, so it's already pulled up right here. That's where we stopped. I think my link should be ready for live. Yeah, there it is. Okay. Okay, so close out of that and paste. There we go. You can just erase it. Alright. Alright, so that's posted, and now I can go ahead and continue. Alright, so we're at line 645. Let's see. So we stopped here. Note, make sure you review the section below up until line 658 after implementing the apply list. The apply list, replacing the order list. Copy, change. Okay. So that was a hastily written. This below section concerning apply list replacing order list. Copy. Okay, I understand what I meant there. So we're finishing up this added in final pass of the timestamp system, where we ended up actually creating a new list called the apply list, so that we have two separate lists we have that are sort of mirrors of one another in a sense. They both contain the timestamp. Yeah, they both contain the timestamps, but the difference is that this order list is it contains more data. Yeah, so this one is actually the order list, and it does contain the timestamps, and it orders them based on the timestamp, so that is the proper name. And then we have the apply list, and this is the list of the data that we want to apply at this current moment, which means it has been 4 seconds since we received we've received the data. Yeah, it's been 4 seconds since we received this data, and it's still ranked as the one as far as the timestamps go. Now I just want to verify this and make sure I understand this correctly, that I have coded this section like on concerning the broader logic. So just zooming out, what we do is we receive the data, we assign current other received string based on the ID, then we assign the whatever this for the logging printout. Okay, and then we append the object to the incoming data, to the receive object list. Then we iterate through the IncData's dircheck timestamp list, and we append that data to the current client's order list. Then we sort the order list. Okay, so that's what I was curious about. I was making sure that we order it like properly as far as the flow of the order of operations and like how we're looping through that order of operations to make sure we're doing it correctly. And that sounds right to me. Every time we receive a new object, we grab it, we extract the data from it, append the data to the timestamp, to the order list, and then we sort the order list so that every time we receive new data, it is sorted again, and that's what we want. And then after we sort it, we assign the earliest timestamp, which is the current client's order list at index 0, and then at index 0 because that's just the timestamp of the earliest, and then the latest will be the last in the list because latest is greatest and it's in ascending order. So that's correct. And then we say if latest timestamp minus earliest timestamp is greater than or equal to 4, meaning that it checks to see if it's been 4 seconds since the earliest timestamp. Yeah, so we check to see if it's been 4 seconds since the earliest timestamp, and let's just re-verify this logic. So we have latest timestamp, which would be the higher number, and then we have the earliest timestamp, which would be the lowest number. So if we have 10, and then let's say this is 10, and then this is 4, 10 minus 4 would be 6. So that means it's been 6 seconds between the timestamps, which means it's greater than or equal to 4 because it's 6. So yeah, that's what we want. And then we have we create the apply list only in this instance, and the apply list is then we iterate through the order list, and we say if toop 0 is less than or equal to. So now we're checking a different strain of logic. Let's see, so we iterate through the order list and we say if the first entry, which is the earliest, earliest received, is less than or equal to the latest timestamp minus 4. And this was where I got confused last time dealing with this. Yeah, for toop in the order list, and then we say if the earliest timestamp is less than, the earliest is less, if that is less than or equal to the latest timestamp minus 4, this is so isn't this basically doing the same thing as this? Because this one we're comparing the latest against the earliest. Okay, so this check lets us know that it's been 4 seconds since the earliest timestamp. This check is to see if it has been four seconds prior to the latest timestamp. But I'm not sure that's how I'd want to do it. I'm not sure that's correct logic. To incurrent line order list. So at this point, what I really want to check for, and let's just write it. What do I want to check for? I want to see if it has been 4 seconds. If earliest timestamp or rather and each subsequent timestamp has been if the earliest timestamp is at least 4 seconds well, we don't actually need to check it against the latest timestamp, do we? We just need to check it against the current time. Like, because by the time we get here, let's say at this point we do have the latest timestamp is at 10 seconds and the earliest timestamp is at 6 seconds. So 10 minus 6 is 4, so it would enter into this as true, which is correct. But since it's only been 4 seconds, well, let's just say, yeah, let's say that this is 10 and then this is, say this is 4. So then it would be 6. So it would enter into it, and then we create our apply list. But then let's also say that not only the earliest timestamp is 4 seconds ahead. This one, the earliest timestamp in this instance would be 6 seconds ahead. But let's say that the next earliest timestamp would be 5 seconds ahead. In that case, 10 minus 5 would also be should also be applied. So in that case, we want to apply not only that earliest timestamp but also the next earliest timestamp as well, and we want to keep applying all of them that we already have in the order list. As long as it has been 4 seconds since we have received that data. Now this makes me say, well, hold up, couldn't I just say I don't even need the latest timestamp? Why do I need the latest timestamp? Why couldn't I just use the current time? You see what I'm saying? Like, if I'm trying to figure out, if the only question that I'm trying to answer is has it been 4 seconds since the timestamp has been received? If so, apply it. I think that is the only question that we want to ask. We don't really care about what the latest timestamp is. So this latest timestamp right here, we could just replace this with, actually I'll do it like this. So I do double pound for what is being replaced, and single pound or directly above it for what is possibly replacing it. So then in this case we would just not even use latest timestamp, and we would actually just say if time.time minus earliest timestamp, and then we would use this as it exists currently. We don't need to modify that. We have double minus, we don't want to do that. So if time.time minus earliest timestamp, so the only thing we actually need is the current time and then the earliest timestamp. If it's been 4 seconds since the earliest timestamp, so if this is 11 and then this is 6, then it's been 5 seconds. 11 minus 6 is 5, which is greater than or equal to 4, so that's what we would want to happen. We would want it to enter in as true in that case, which it would, so that's correct. So we're just going to get rid of latest timestamp. So what I'll do is I'm going to search for latest timestamp, and this is why you always go back and review like twice, at least for me, because I'm kind of dumb. So like the first pass is always going to have some sort of like way that it could be improved. It's never going to be perfect the first time around, and you know, getting rid of this, it makes thinking about the problem a lot more simple. So anyway, we're going to get rid of this entire line because we are not going to actually use timestamp. Let me just think for just a second though before I get rid of it. Am I absolutely certain we don't need latest timestamp? Just trying to think, what would we need the latest timestamp for? Well, we might need it for what? For why would we need to know what is the most recent timestamp? We don't need to compare it against the earliest timestamp, because all we need to know is has it been 4 seconds, which doesn't require the latest timestamp variable. Yeah, so I'm, you know, I am a little slow, but I don't believe that we do need the latest timestamp at all. So I'm just going to nix it. So we'll say, what's this? Assigns latest timestamp to the last latest timestamp from the order list. So that's gone. So there goes possible bugs and a more clear line of thought. And then we're gonna get rid of this line and replace it with this one. We're gonna uncomment it out because we are gonna use it, and then we're gonna change it to say, see if it's been 4 seconds since the earliest timestamp. And actually my comment is right on the nose as far as what we were actually trying to accomplish. So yeah, if it's been 4 seconds since the earliest timestamp. And just to verify, time.time, it works as I expect it to. We're going to open up test reminders. We're going to go down here. We're going to say import time, and then we'll say now equals time.time, and we'll print now, and it should print out as a float. So then we'll do cd to testing, and we'll do pi test reminders dot pi, and so yeah, we get that float number. So if we say this is then, or we'll actually say then, and then we'll put print then minus now, well, actually, that would give us a negative number. At least I'm pretty sure it would. So then now minus then, this should give us a positive number. Hold up. So now is bigger, and then would be smaller. Isn't that right? So why does it give us 0? That's strange. Let me just double check this to see if it has something to do with printing it. So we're gonna say the difference equals now minus then, and then we'll just print the diff. So let's go ahead and print the diff, and it's still showing as 0.0, but I don't think that's right. So we're gonna print then, and we're also gonna print now right after it. So to do this even with more clarity, we'll put f then equals then, and then now equals now, and I didn't do that correctly. Then equals then, and now equals now, and now that's closed. So we print then, we print now, and then we print the difference, which is now, which is later and greater, subtracted by then, which is earlier, so it's lesser. So the greater we're subtracting the lesser from the greater, so the difference should not be 0, because you can see then is 171.0261256 dot 0.88610053, and then now is the same second, but it is 86. Wow, it's actually the same. It's that fast? Or like, hold up, because how do you, let's say, how do you do sleep? It's Python sleep. Time.sleep, and then you put the time in there. So then we'll say, I'd like to make sure, so we'll say time.sleep, then 1, and let's try this again, see what the result is. Okay, so you can see that, because I was wondering, I'm like, is time.time functioning differently than what I thought it did? Meaning that, like, for some reason these two times were considered like the same for whatever reason, but at least whenever I put time.sleep between them, there's a whole second between them, as you would expect. So then is at second 26, and then now is at second 27. So that's what I would expect, but it makes me concerned about using time.time without using sleep between, because like in this instance, even though they're not simultaneous, the script is considering them to be basically equal, like actually equal, not basically but literally equal. You see, it's at second 92.55 or 5995984, and this one is the same thing, 2.5995984. So there's not even a tenth, hundredth, thousandth, 10,000, 100,000, millions. There's not even 1/10, 10 millionth of a second difference in the time it takes to execute this line and this line. And that actually might be problematic, so I think this is why people probably prefer to use time ns, which is nanosecond. And honestly, I don't know exactly what a, like, isn't a nano like a millionth or something? Nanosecond. Yeah, nanosecond is a billionth of a second. So let's look at this. So we have, where's that? I just want to see the little diagram. Okay. Where is it? Here we go. This is what I wanted to see. So a millisecond is 1/1000th. Then it's a microsecond. So these two lines, what did we say? It was 1, 2, 3, 10 or 10. Let's say 0.1 second. A tenth, a hundredth, a thousandth, a 10,000th, a 100,000th, and then a millionth, and then a 10 millionth. 1/10 millionth. So this is time measures up to the 10th of a microsecond. Is that correct? Let's see. What is it? Python, does time measure up to the millisecond? Not millisecond, I'm sorry. Microsecond. Microsecond. The second in seconds time unit, how to measure. Is Python time in seconds or milliseconds? Seconds since the epoch. Get current time in milliseconds. How precise is time? Okay, yeah, so it's provides timestamp with 15 up to 15 milliseconds resolution. But and this is really just something for me to learn. And the most accurate way to measure time in Python. And then let's do nanosecond. Let's see. So a nanosecond is another, like a nanosecond, according to this diagram, yeah, is another 1,000 times, or rather, a nanosecond is 1/1000th of a microsecond. Did I say that right? Because if a microsecond is 1/1,000,000th of a second, and nanosecond is 1/1,000,000,000th, that means if you have a nanosecond, or let's say a microsecond, which is 1, and then 1, 2, 3, 4, 5, 6, and now if you multiply that times 1,000, then you have 9 zeros, which is a nanosecond. 3, 6, 9. So yeah, a nanosecond is actually 1/1000th of a microsecond. But we're not actually comparing, like, we're not comparing data by the second. Or the nanosecond or anything like that. We're comparing it based on 4 seconds. So this shouldn't actually be a problem. I was starting to get concerned. I'm like, wait a second. Well, if it's not precise to the like, you know, saying that two lines of execution were not visibly separate when comparing the time using time.time, then it might cause a bug and say that the two times were equal. But I don't think that would ever be an issue because we're measuring on a 4-second difference. That's the check. The checker is for 4 seconds. So I don't think there would be any issue. Yeah, I don't think there's any problem using time.time. But since I'm already looking at it, I want to look at what using time.time_ns, which is nanoseconds instead of microseconds, does. So wow, they're even equal to the microsecond. That's insane. They're even equal to the microsecond. That's crazy. That's insane, dude. No way. No way that those two lines of code are that's insane. Whatever. It doesn't really matter, but I just didn't think that the execution was that fast. That's so fast. Oh my god. That means there's not even 1/1 billionth of a second between calculating then and now. Totally insane. Reminder that time.time calculates to the microsecond, which is the 1/1 millionth of a second, while time.time_ns calculates to the nanosecond, which is 1/1 billionth of a second, which is insanely, like, an insanely small measurement of time. Absolutely astonishing. Anyway, so we're done with that. That's not a problem. That was actually a waste of time. If I would have just remembered, we're only measuring by 4 seconds. Actually, though, let me just to be absolutely certain, let's do this. We'll re-enable this, and then we're gonna say then, and then we'll put time.sleep, and we'll put 4 seconds between. So now there should be 4 seconds between time dot, and we're gonna use time.time instead of time.time ns. We can use time instead of time ns. So we're gonna use the standard, more typical, basic version, and it's gonna take at least 4 seconds because it's got to count for that sleep. Okay, so now it shows the difference correctly. It says this was at 9:54, and then now it was at 9:58, which is later and greater. So yeah, the difference is now, which is greater, minus then, which is lesser. And the answer is, or the difference rather, is 4 seconds. And that is exactly what would happen. But even actually say if the diff is greater than or equal to 4, print the diff. So only if it's greater than or equal to 4. If it's not greater than or equal to 4, then it's not going to print the difference, but you can see it did print the difference. So that's coded correctly, and let's make sure that our actual code reflects that, yeah. If this would be then, and then that would be minus now, so then is, well, I'm sorry, this would be now. So now is greater. So if now, which is greater, is less than earliest, which is lesser, so let's just say 10 is now, 5 is earliest. So 10 minus 5 equals 5 is greater than or equal to 4. Yeah, then it's going to enter into that. So that's correct. That's exactly what we want. That's good. So now we can close this. We're done with that. We're going to CD back out of test reminder testing and go back to main. Now, so time to time minus earliest time times greater than or equal to 4. Apply list. So we create the apply list and we say order list. We iterate through the order list. So if it's been 4 seconds since the earliest timestamp, then we create the apply list. Then we begin iteration through the order list, and we check to see if the earliest timestamp and each subsequent timestamp is at least 4 seconds prior to now. In other words, that would mean we would say if time.time so we're actually just asking the same question again, but okay, so here's a little bypass we can do. Since we know that at least one of them, meaning the earliest timestamp, it is earlier, then we can create the apply list with this timestamp already in it. So we'll say the apply list is equal to, we'll put the and how do we want to populate the, well, the apply list is basically supposed to be a mirror of the order list, isn't that correct? It's supposed to be like a subset of the order list. So for TOOP and current client or check order list, yeah, so this will consist of the apply list, that is, will be the current client or check timestamp order list at index 0, because that's the first item in the order list. Okay, so that makes sense, and every time that we create this apply list, this value would be correct because the order list is depopulated after, like, it is depopulated after this section that we've just entered into. All this that I'm highlighting is run. So referencing at index 0 of the order list at this particular line, I'm quite sure would always reference the earliest timestamp entry. So that's good, and then we'll say for TOOP in current client or check timestamp order list, and we're actually going to start from index. We'll start from index 1 to the end, and I'm a little bit rusty on my using indexes. It's hard for me to remember exactly, like, do I put 2 colons or just one. I can't remember exactly. So what we'll do, I will create a list called L, and it'll have 1, 2, 3, 4, and 5, and then we'll say print L from 0 onward. And I want to say that we're going to go back to testing, and then we're going to run test reminders. Yeah, well, that prints everything. But then if we do 2 colons, what does that do? It's the same thing. Oh, that's for step. So this would be like, we'll say this is where it begins, but is before the colon. Then where it ends is after the colon. So then we'll say -1, which is the last entry, and the step, which is after the second colon, is going to be, let's say, 2. So it's only going to print every second element. So yeah, it starts off at 0, and then it skips. Well, I thought it said 2 steps. But if it said 2 steps,
Are they?
if it's 2 steps, well, let's just change the step to 1. Okay, step to 1 just means well, that's not right, because in this case it should print out everything. If it, oh no, because it excludes the last index. Yeah, if you leave it blank, it's gonna print out everything. And then the step is 1, so it's printing out everything from index 0 all the way to the end, and then it's stepping every one element. But if we change the step to 2, it should print out 1, 3, and 5. Okay, yeah, so it's skipping. And then if we change the step to 3, it's going to print out like 1 and 4. Yeah, okay. If we change the step to 4, it's going to print out 1 and 5. And then if we change the step to 5, it's not going to print out anything except 1. Okay, so now I understand that again. And then if we change this to -1, this is going to print everything except for the last element, because it's excluding this last element, which is key -1. So then if we did what I actually want to do in the code is I want to print everything except the first element, and that would be like that. So we would reference it as 1 and then colon. So 1 and then colon. Hold on 1 second. I'll be right back. Okay, I'm back. I had to grab something really quick. Alright. So, yeah, what we want to do is access from index 1 onward. Just put a reminder of that. L at 0 2 will print out everything starting, well, actually we'll just put starting element finishing element, or rather starting index, finishing index. Actually, this would be excluded index, because if we did 0 to -1, it wouldn't print out the last element at index -1. And then this is the step amount, or we could also call this the increment. Time for my anti-inflammatory for my back. Popped it. There we go. Alright. Okay. So we're good. We're good there. So we want to print out, or we want to iterate through the order list, but only the order list from the second element onward, which means we're excluding index 0 because it's already in the apply list, and that means we're gonna start iterating from index 1 all the way to the end of the order list. And then we say if the earliest timestamp, which we're actually not going to check that because that one's already in there, we're going to say if each subsequent timestamp is at least, say, from the earliest timestamp is at least 4 seconds before the current time. Before the, yeah, we'll just say the current time. It's not actually going to be a variable, it's just going to be executed as time.time. So then we'll put below line created 3/12/24 checks to see if each subsequent timestamp from the earliest timestamp is at least 4 seconds before, and then this way creates the apply list, which is used to apply filtered data, to apply any data that was received at least 4 seconds ago. Yeah, so as long as it's been 4 seconds since we received the data, then we will apply it. Okay, and creates the apply list, which is used to apply any data that was received at least 4 seconds ago from the order list. Can't type it all. That was received at least 4 seconds ago. Is pre-populated containing the earliest timestamp entry, since we know that in this case it already has been 4 seconds since its reception. Okay, that's exactly what we want. Now, so apply list is equal to a list consisting of the current client order list index 0. Then we iterate through the order list, excluding the index 0, and we check to see. I forgot to put this data transfer modification header, whatever you want to call it. We'll say check to see if each subsequent timestamp. Check to see if it has been 4 seconds. If it has been 4 seconds since data reception for each subscript. Okay. Checks to see if it has been 4 seconds since data reception for each subsequent timestamp entry. So yeah, if the time, if now minus 4 or minus, or rather time minus 20, because that's going to be the tuple in the order list, and then we want to access the index 0 of that tuple, because the tuple consists of various things. At index 0 it references the actual timestamp, so that's what we want. We want tube 0, but is this in the correct spot? So if now, which is later, is minus, so if a greater number now minus an earlier number is greater than or equal to 4, so it's pretty much the same exact thing as this, then so we're replacing this line with this line, so bam, and then if it has been 4 seconds, if now minus before greater minus lesser, so let's just say 10 minus 6, which is 4, is greater than or equal to 4. Don't forget your colon. There we go. Then apply list dot append the tuple, and we want to append the entire tuple, not just the timestamp, because we're going to use the data from in the format that it's in the order list. We're going to extract it and manipulate it to construct the actual dircheck call for that associated data, so that we can actually receive the data. And once we reach an element that it has not been 4 seconds since we've received that data, then that means we can go ahead and break out of the iteration, because the order list is already sorted in ascending order, meaning that if once it encounters one element that it has not been 4 seconds since from now until then that means all the rest of them, since they were received later, definitely would not meet the 4 second requirement. So that's why we have break right there. So this is actually a lot better now, and we'll put that in the devlog that we fixed, which devlog is already open over here. We'll put reviewed. We'll just say lines 630 to 645 until.py the transfer modification section we were working on previously. Section we stopped at last session and found a couple bugs and ways to improve the logic. Changed, we'll say deleted latest timestamps and replaced with time.time, since we are only concerned with the amount of time that has passed since data reception, meaning we actually don't care about the latest time stamp at all. Okay. Oops. Now we will go to the next section. Alright, so this is where we had actually stopped. So I'll remove this. But make sure you review section below here up until line 68 after opening up the apply list, replacing the order list copy change. Okay. And it says apply all entries in the actual apply list. So I'll leave this note. I don't want to delete that because I probably need to do what that says before I'm done. But we'll do this line first. So apply all entries. I don't want any. I thought I removed this from my. Yeah, I don't like that. Okay, now we're applying all. So should we be indented here? No, we don't need to be indented here. So we should be at this indentation. So we're gonna leave this commented out, and we're applying all entries in the actual apply list. So isn't that what this line right here is doing? So it says for toop in apply list dot copy for toop. Okay, so we're replacing this. We're replacing this line, which is the order list, with the apply list. So instead of iterating through the order list, we're iterating through the apply list. Okay. And then we say for current object equals current client dot receive object list at toop2. So all this is going to be the same, and that's why we were saying we wanted to append the actual tuple from the order list directly as it is, because that will allow us to basically treat the apply list as a subset of the order list, which will make application logic a lot more simple. You know, there's no reason to overcomplicate it. So we can get rid of these two lines, because I'm pretty sure this right here is accomplishing what is accomplishing that. So yeah, so now we iterate through the order list. If it's been 4 seconds since the timestamp for that data, we append it to the apply list. If not, we break out, and now that the apply list is properly populated with all the data that should be applied, now we can check our comment for this line, which says begins iterating through a copy, because at the end of each iteration we pop the element we just iterated through of the apply list to apply their check data in order of timestamp. Okay, that's good. So it says for toop in apply list dot copy. Yeah, and we want to create a copy because we are going to be popping. Well, actually, okay. So this is a question about: do we need to pop from the apply list because we recreate the apply list every time? I guess I don't think we actually need to pop from the apply list after we apply the data, but we do need to pop it from the order list because the order list is actually what is extracted from to populate the apply list. And like we said, the apply list is just a subset of the order list. So I think what we have done here is correct, where we say for toop in apply list.copy, because, well, actually, if we're not going to be popping from it, then we don't need to create a copy of it. So that's up for grabs. Let's just go ahead and look at the next line. This originally said for toop in the order list.copy, and then we assign the current object based on the receive object list at toop2, which is going to work just as well because this toop in the apply list is literally the same exact thing as in the order list. And let's just read it to make sure it's clear and precise. Current client's received object list at toop2. We know toop0 is timestamp, toop1 is dir string, and toop2 is going to be the index of the object in the receive object list, and that is the format in which we are using toop2. It will grab the index of the object from the receive object list, which is correct. Then we say if current object ID is equal to current ID, current rather is equal to current, blah 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 blah, other arg is equal to false. And if object ID is not equal, if current ID is not equal to current client ID, then current or other equals other, and then other client arg equals true. Alright, now that's good. If toop1 is equal to player or toop1 is equal to game, so none of this is gonna be changed. I was just double checking it. We already double checked this though. I'm not gonna go through it again. We actually went through this like 3 times. So I feel very confident. I usually have this rule of like, and I actually have a format for it where I put 4 asterisks, 1, 2, 3, 4, after the each line. I'll comment and then put 4 asterisks, and that means that I have checked this line 4 times. That means I went over it and reviewed it 4 times, 1 asterisk for each time I review it, and it just verifies that there shouldn't be any bugs in it. So and we do want to make sure we're popping from the object list. I already think that's taken care of though, but let's just keep going. So we iterate through the apply list, the copy list, we assign all the proper args, which is what all this is doing, and then we end up with calling dir check using these various arguments, and we had already checked that a couple times, and I'll actually just put 2 asterisks here because I'm pretty confident we checked that twice. Anyway, then we'll put delete current client dir check timestamp order list at index 0. So we're deleting as we iterate through. But now, since we're not actually iterating through the order list, we can. Okay, yeah, and this, I was asking about receive object lists being depopulated properly, and we do have the code for that. Let's just double check this section one more time just to make sure it's right. So we say delete receive object list entry bool. It starts off as true, which is a switch. True meaning we will delete, false means we won't delete that entry. Then we iterate through the order list to check to see if the tup2, which is the index of the item in the receive object list, is equal to still exists inside of the order list, because we had already just removed the data entry we had just applied. So now we're checking to see, well, is there any other entry that has the same index, meaning it comes from the same object. If it does find one, meaning that if it is order tup at 2 is equal to tup at 2, then hold up though. What? Okay, yeah, tup at 2 is we're iterating through that way up here. So like, yeah, we're still iterating through this tup. So this is a proper reference, and order tup at 2 is a reference to each tuple in the order list. Okay, and if we do find a match to that object, then we say the bool is changed to false, meaning we don't want to delete because there's something else in there for that object. Then we break out, because as long as there's one other entry, we don't want to delete it. And then we check to see if the boolean is equal to true, and if it is equal to true, then we delete, or remove rather, the current object from the receive object list. And that goes by the object and not the index. But I was just wondering, that's why I paused for a second, is what if since when we use time.time, since the times were considered equal to each other even though they happened like directly after one another, do you think that could be possible where we would have two objects sent over with the same directory string? Well, we actually don't have the receive object list just consists of actual objects, but this just makes me ask, since we're using remove, does that, like, is that a risk? It seems like it could be a risk, because I'm not absolutely certain in what format these objects exist as. Meaning, like, are they... well, they're gonna be... basically, what is their repr? And if you know what I mean by repr, like, whenever you print out an object, that's what gets printed. And I want to say repr is also what is checked for, like, when we say remove current object and then the interpreter says, okay, well, what actually is the current object, that's gonna be like whatever the receive object list actually calls this object, like its ID or whatever. And if that object is actually like just a class instance object, meaning okay, so let's say we're sending over the client object, from the server side, which is what we do, which is what the receive object list is populated with. Since the receive object list is populated with a class instance of the client object, it will say that the receive object list at index 0, when we like print, what is it? It will say client object, and then it'll say at, and then like some memory, I forget like what you call it, but it's basically the object's identifier. It's like a specific identifier for that object. And if I understand this correctly, if we were to send that same object again, and I'm sorry, I think what actually that key, the identifier I was talking about, is it's actually where that object is located in your computer's memory. Which means even if that object has been modified and then sent again, it will actually still reference, it will still be written out the same. So if you were to check for equality between those two, well, okay, I don't know if you were to check for equality between the two objects that they would be found to be equal to one another, but I do know, at least I'm pretty sure, is that if you were to check for that item in a list of items, even if it was a second entry of that same object, this remove method would actually find that second object and say, hey, here it is. Which means this is a risk, because what we want to do is we only want to remove the exact object entry that we're dealing with. But when we execute this line, it is not necessarily going to remove the one that we're dealing with. It's going to remove the first occurrence of the object with the same repr. At least I think, anyway. That's like a proper way to word what it's going to do. It's going to look for that object at that specific point in the memory. Let's just say it's called client object at x01. So then it's, if we had sent two client objects over and they're the same client objects, which they will be, then that means when it is looking through the receive object list, let's say the current object we're actually dealing with is the third entry in the object list, but at the first entry in the object list there is the same object, client object at x01. It will not remove the third entry as we would expect, or as we would want it to, but instead it would delete the first entry, and that is not what we want. So we need to, I need to review this and verify, and I'm just going to put a comment for now, and we're going to actually add that to things to do, because that is very important, and that would probably be a bug that would be kind of hard to discover in hindsight, but it's a lot easier to find beforehand like we just did, which I'm pretty sure it would have been a bug if I wouldn't have caught it. Pop me here a piece of this gum. Okay, so I'm getting a little sleepy. Been up since, actually I got to go to work late today. We went in at 5:45. We usually start at 5:30 today, so I got like extra 15 minutes of sleep, but I haven't been sleeping very well, so a little bit sleepy. Coffee's not really doing the trick for me. Which I've been weaning myself off of. I've weaned myself off of a few things. So for one, I was taking like a non-stimulant stimulant called armodafinil to help keep me awake when working really long hours and stuff and doing coding. It's kind of like Adderall light, and it had some bad side effects. I quit. I like weaned myself off of it. Only took it for a couple of months, and I was like, nah, it creates more of a crash than like what it's worth, and it gives you like anxiety and stuff like Adderall does. So I quit taking that, which I didn't take much of it, but I have low tolerance. So anyway, I weaned myself off of that, and I also was taking like Tylenol PM and melatonin to go to sleep, so I would get good sleep. But over like the past 2 years, I went from taking 1 melatonin and 1 Tylenol PM to taking like 3 Tylenol PM and 3 melatonin to reach the same effect, and I felt like it was actually causing me to be more tired throughout the day. So I weaned myself off of that too, to where now I take virtually, I don't take any armodafinil, and I don't take any melatonin or Tylenol PM. I actually take like a couple melatonin drops right before I go to sleep, and like a tiny piece of a Tylenol PM. So I'm also trying to wean myself off of coffee. I was up to like 3 coffees a day. Now I'm down to like 1. And I'm like at the end of my first cup. I only have like 1 sip left. So, like, damn it. It's a little early. I don't want to drink a second coffee though. So anyway, we will. What were we doing that I got distracted telling you that, which was not important at all? Oh yeah, the caution comment for the receive object listing. Definitely a thing that needs to be reviewed. So we'll say below line comment added 3/12/24, and then we'll put when reviewing this line, I noticed that remove will grab the first match to the sought after object, and in the case of this receive object list, I think that it will be populated with, let me just say, client object at memory 0 or x01 multiple times, meaning that it will find a match that isn't the actual sought after object TLDR. It will remove the first instance of the object instead of the sought after object. Okay. And now, oops, that's what to do. Now we'll go to things to do. We're gonna add this rework. We'll put it right here. When reviewing what line? That is line number 706 in ClientPy. 706 in ClientPy. I noticed that removal grab the first object. In the case of this, I think the will be populated multiple times when you find it much. It isn't the actual sort of object you can write remove. Of course, this is put that on a separate line. And then we'll put need to review this line to verify this would be the case, and if so, offer a remedy to the bugged code. Okay. And we're not actually at that anymore. Okay, now we'll finish this. So we reviewed this. What we're gonna. So how can we actually verify this? This is something that okay, so I feel like there's a ghetto way that we could test this in the test reminders file by creating a class. We'll say CLS class CLS, and then def init self double underscore, then we'll say self dot x equals 1, self dot y equals 2, and now we'll say c1 equals CLS. So we're creating an instance, and then we're going to create a list which has we'll just make it empty, and then we'll say l dot append, and then we'll put c1, and now we're gonna change c1 dot x to 3, and then c1 dot y to 4. So we're modifying the c1, and then we're gonna append to the list c1 again. And now I want to print out L, which should print out these two different client objects, or just, well, we just call it class. So then we'll run that. That is not the right syntax, and somehow I knew that was wrong, but I just, for whatever reason, it's, is it because I capitalized the C? Okay, yeah, it was because I capitalized the C. It's supposed to be lowercase c. Lowercase c class, so that's the class name, and then this is the initializer, then, or instantiator, whatever. And then self.x is equal to 1, self.y is equal to 2, c1, which is an instance of the class CLS, and L, which is an empty list. Then we append c1, which is the class instance, to the list, and we change c1 a little bit by modifying its two attributes, and then we append c1 to the L list again, and then we print L. So L consists of the two client objects, and as you can see, just like I said, it says underscore underscore main underscore underscore dot CLS object at, and then this is the memory slot or spot, whatever, like the location in the computer's memory at which it exists in the form of bytecode or whatever that's called. I think it's called bytecode. Is that bytecode? It's not important. Anyway, so let's just read it. And you only have to read the last few because it's like a time string, a time float. Most all the first digits are going to be the same. So it's 0x and then 1, 2, 3, 4, 5 zeros. So 0x and then 1, 2, 3, 4, 5 zeros, and then it's 2283C2, and here is 2283C2, and then D9CD0, D9CD0. So you can see that these two objects are actually considered to be the same object, even though they have been modified and whatever. And this is pretty much the same concept whenever we send the objects over the network. At least I think it's pretty much the same thing. like the only difference is that we serialize the object first and then we deserialize it. But I don't think that serializing and then unserializing an object makes it like a different object. You see what I'm saying? So let me actually look real quick for dumps. So we're gonna say dumps, which is the method that is used to create so dumps is the method called on the pickle module to serialize this past object argument, which is the current client. So let's go ahead and pretty much just copy this line, but I think we might have to import pickle. Let me see if I have to import pickle or is pickle built in. I want to say pickle. No, it's not built in, so we do have to import pickle. So we'll go back to the test reminders, and we have copied the line already. We're going to go all the way up to the top, and we're going to import pickle because we need that for serialization. Pickle, I think, is the fastest one. I did testing on all that, and it was, it was the fastest one. So now what we're going to do is, since we have initially created the object, we're now going to say data. We'll actually call C1 pickled or serialized is pickle.dumps, and we pass in C1, and then we will actually do that again when we so what we're doing here is we're creating the instance of the class. We're serializing the instance by calling pickle.dumps on the C1, assigning that to C1 serialized, and then we're going to append the serialized version. So this L is going to act like our transfer list, and then because we have to transfer it in the form of a serialized object so that it can be transferred over the network without like destroying the object, and it's like you have to translate it into a different format for it to be transferred over the network into bytecode or whatever. And now we're going to modify the C1's attributes just as we did before, and we're creating C1 serialized again, but just for clarity's sake we'll call this C1 serialized 1, and then this one is going to be C1 serialized 2, and this is going to be the same exact thing though. We're calling dumps on C1, and now we're appending C1 serialized 2. So we have L append C1 serialized 1, and then append C1 serialized 2, and then we're going to go ahead and print well, actually what we want to do now is we'll say deserialized L, and that's going to be, well, I'm sorry, we'll do this. We'll say for C in L, which is going to iterate through L, we'll say C, which is it's going to iterate through C serialized 1 and then C serialized 2, both of those serialized instances, and then we're going to call pickle dot, what is it? There's pickle dot dumps and then pickle dot, can't remember. It's avoiding my, it's avoiding me right now. It's not dumps, of course, because that's, I had them backwards too. Like I would get confused with dumps versus the other one. Okay, loads. Loads is when you unpickle it or deserialize it after it has been serialized already. Pickle is, or dumps rather, is when you are actually, like, picture like this. You have an object and you're dumping it off of a truck, and as it's being dumped off of the truck, it's being turned into a different translated object, which is it being pickled or serialized. It's being dumped off the truck into a serialized format, and then when you receive it on the other side, you are picking it up with a different truck, and as it's a serialized object when you pick it up, but after you load it or call loads on it, you have retranslated it back into the original object format. So yeah, it's called pickle.loads instead. So we'll go over here and we're gonna have this line say iterating through L. We're gonna say for C and L pickle.loads, and we're going to call that on C in L, and now we're going to print L and see if it's the same thing. So let's see, let me just check and compare it. Did I do something wrong? Okay, no, this is still in bytecode, but it shouldn't be, right? Because I called loads on it. Let me just see. Print C. Okay, no, it's still... Okay, see, you can see that the ending is different because we modified it. It's XO4UB, but this one's XO2UB. So there is a difference. But I thought loads was supposed to restructure it. Oh, we have to assign it. I see now. I see. We have to say C1 deserialized equals C1 deserialized 1, and we'll say equals okay, I've kind of confused myself a little bit with this. For C and L, C1 deserialized 1 equals pickle.loads at C, and then we print, well, we don't want to print C, we want to print C serialized 1, and we'll just call it C1 deserialized, and let's see now. Okay, so now we did it correctly, and let's see, they're equal again. So we can just look at them on top of each other. 27E5, 236A4B. Well, no, they're not actually equal. See, this one is a little bit different. This one is 480. This one's 4B0. So this B versus the 8 is the difference in these two attributes that we changed. So okay, well, that's good then. That means that, at least I think, as long as the object is different, and it should be, because meaning as long as any data, as like within the object, meaning any of the attributes of the object have been altered from the prior version, then when it is transferred over the network and subsequently deserialized, then it will not be, it does not have the same signature as far as what is looked at, what is checked whenever you are searching in a list of those objects, it will not find equality between those two objects. So let's verify that by so here's what we're gonna do. We're gonna say actually we're gonna get rid of this line, and then we're gonna print L, because I want to verify that L does indeed reflect this. No, it doesn't, for whatever reason. So we have, okay, how about this? We'll say L1, and then we have L2. So we have the sending list, and what do we call this? Send list, and this will be the receive list. Yeah, there you go. So we have the send list and then the receive list. We want to append L to the send list, and then we want to, okay, let's start from the beginning. We import pickle. We create the class CLS. We initialize it with two attributes, x equals 1, y equals 2. We create C1, which is an instance of class. Then we serialize the C1 object using pickle.dumps. We call that object C1 serialized 1. And then we create a send list and a receive list. We then append to the send list C serialized 1, which is the serialized version of the C1 instance. Then we say C1.x is equal to 3, C1.y is equal to 4, and that is going to modify the two attributes for the actual C1 instance object. Then we create C1 serialized 2, which is a pickled version of the modified C1 instance. We then append to the send list the second serialization of the C1 object, which is C1 serialized 2. Then we iterate through send list for C in send list. We then are now deserializing the objects that have been serialized, which exist in the send list, and we call pickle.loads on each object in the send list, and when we call the loads method, the object that is returned is C1 deserialized. And then we're going to say receive list dot append, and then we will append the C1 deserialized. And actually, to be even more accurate, we'll say num equals 0, and then we'll say for C, and each time we iterate through C, or iterate through the send list, we'll say if num is equal to 0, which means for the first iteration we will call it C1 deserialized 1, but else it's going to be C1 deserialized 2, just to show that even though we have this pickled object or unpickled object as C1 deserialized 1, and then we have another C1 deserialized 2 unpickled object, because actually, let me just show you. We're going to do num equals 0. We're going to iterate through the send list. The first iteration, when num is equal to 0, it's going to do 1 after the C1 deserialized to create the first object, and then we're going to say now after this iteration num is equal to 1, and then it's going to iterate through it again, but since num is no longer equal to 0, it's going to enter into the else, so then it's going to create C1 deserialized 2. So there's going to be two separately named objects, just like for clarity that they're two different objects. And then we say the receive list, yeah, we're going to append each object to the receive list. So right, for this one, we would put receive list out append D1, C1 deserialized 1, but then this one is going to be receive list append C1 deserialized 2. And then if we print the receive list, what we should get is a list consisting of these two different objects. And actually, to view them for a quality comparison, we can say for x in receive list, and then we'll just put print x, because this will print them one after the other instead of next to each other. So now we can directly compare them, and you can see that one of them signature is the signatures are the same up until right here. This one is A810, but then this one is A960. But preceding the A, or up until the A, everything's the same. 0x00024223D28A. It's the same thing. But since we changed the attributes of one of the objects, we are able to detect that those two objects are not equal to one another based on the changing of those attributes. Now, let's just say we only changed one attribute. Let's just say we only changed the Y. Would it still? Yeah, it's still different. It's still up to the same up until the after the A, but then it goes from 7E0 to 930. So it, even if you just change one attribute, let's just give it a third attribute. We'll call it Z, and that one equals 3, and then we'll do dot A, and that one we'll say this one equals chicken, and then self dot B, which equals eggs. If we only change C1Y, so 4 from 2 to 4, and we print this out, everything is the same up until this 1. After the 1, it's different. 3, 2, 8, 10, but this one is 0, A, 9, 30. And now, to verify that the difference in the naming of the object is contingent upon the changing the attribute, if we comment out this line, which means now both of these objects are going to have the same exact attribute signature, there I was wrong again. So I'm an idiot. It doesn't actually matter if you change any attribute. Apparently, if you pickling it is what changes the object signature, because that is only the memory location. It is not anything to do with changing attributes. So I'm an idiot. I was wrong. The last like minute of me talking was hot wind. That was bullshit. That's not true. It doesn't matter if you change the attribute. It only matters if the object exists at a different location on your computer's memory. So disregard what I said about changing the attribute. Just to verify, as you can see, there's no difference in the attributes. So to verify that, we'll say for X in receive list, we're going to say print X dot X, and then we're gonna do print X dot Y, then we're gonna do print X dot Z, and then print X dot A, and then print X dot B. So this should print out the X, Y, Z, A, and B attributes, and if I'm right now, these should all be the same for both objects. So we have 1, 2, 1, 3 chicken eggs, 1, 2, 1, 3 chicken eggs. So all the attributes are the same. There's no actual comparative difference between the two objects as far as the attributes, but they still, as you can see, have different memory signatures. So these are memory, I guess you can call it a memory signature. This is where it exists in the computer's memory, which means let me see, how do I word this? The thing that determines. So, all right. Then the question is, if the attributes are exactly the same, and we search for the objects in a list that contains both of these objects using remove, will it be able to? Will it mistake the second object for the first object? Because the attributes are the same. Does this mean that since they're at two different locations in memory, are they considered the same object, or does this mean that they're now considered different objects? Well, let's go ahead and see. So to test that, we will say if, and actually I would rather format this in a different way. Do x, y, and then x, we had x twice, x, y, then z, then a, then b. So now we can print this all in one line, and so it's got x, y, z, a, and b, and then we'll say for x in receive list, if actually first we will say sought after object equals receive list at index 1, which means it's the second object in there, and then we'll say print sought after object, and then we're gonna say receive list dot remove and sought after object. Now if when we print it, first we'll print receive list so we can see it, and then we're gonna print the receive list after we removed it to see which one removed from the list. And if the remove method determines that the sought after object, which is the second element in the list, which we would say is this object right here, 227E0, if remove says, hey, this is the same thing as well, it jumped around on me. Yeah, so it says if remove says that, hey, the attributes for these objects are literally the same, so I'm gonna say that 227E0 is equal to FAAB0, and then it removes this one because it's the first occurrence in the list, then we know that remove searches based on like attribute and object equality, and not the repr that is returned whenever you print the object, which is returns the memory identification. So let's see. So let's just review this, and first off we can comment that out. So now the only thing that happens after what we had done before is we assign the sought after object to index 1 of the receive list, which is the second object, the second element in the list. There's only two elements in the list. and then we print sought after object to ensure that it has the proper memory identification, so we know which one that is. Then we print out the receive list before we remove. I don't know what happened there. So this should have both of them, and we should see that the sought after object is indeed the second object in the receive list, and then we call receive list.remove the sought after object, and if it will delete based on the memory key, then the second object should be gone and the first object should remain. But if it doesn't work that way, then the first object would be gone and the second object, the actual sought after object, would remain. So let's go ahead and run this and see what we get. Alright. Do we have another print up here? Okay, so we print the sought after object, which is actually, we can just print out the last, let's see, it's the same up until AA, and then it's B10, and then 540. So it's fine as we printed it out. So first we print the sought after object, which is B10, and then we print the receive list, which is A540 and then B10, so you can see that the index 1 assignment worked and that it's B10 is indeed the second object in the list. Then we call remove on the receive list, removing the sought after object, which should remove B10, and as you can see, it did not remove the first object, even though the first object has the same exact attributes and all that as the second object. There's literally no difference between them. They're actually the same object, but because we serialize them, and just to double check that, first we're gonna comment out all of this section right here, and then we're gonna put C1. We'll print out C1 after we create it, so we'll say print C1, and then after we modify, let's modify one of the attributes, which we deleted that line. It was at a particular spot. I wanted to keep that spot and I didn't want to have to find it again, so I'm just going to use undo to find it. It's a lazy man's help. It's between send list append and C serialize 2. So in between send list and C serialize 2, we're going to say C1 dot x equals 7, and then now we're gonna print C1. So after we print C1 after we create it, and then we're gonna print C1 after we had modified it. Now remember, we're not actually modifying C1 when we call dumps on it. We're only returning an object. We're basically calling this method on C1, and it returns a new object, which is what we assign C1 serialized 1 to. So whenever we print out C1 here after creation of C1, it should be at a particular index, and then at a particular memory location, but then even though we modified the attribute thereafter, when we print out C1 again, I would expect them to be the same. So it should be the only two things that print out, and as you can see, they are indeed exactly the same, even though the attribute has been changed. And to verify that, we can first we'll say print C1, and then we'll say print C1 dot x. So even though the C1 and the C1 x's are going to be different, the location of the two objects as far as where they are in the memory is going to be the same. So here you can see they're the same object at A4 E0, but the x for this one is 1, and then the x for this one is 7. Now in this case, if we were to check for the, now what we'll do is, let's do this, we'll say we'll just have another list. We'll just call it L, and we're going to actually say L is equal to C1. But then after we modify C1's X, we're gonna then append C1 to L again. So now we have C1 in its original form and then C1 in its latest form with the modified X attribute, and we're gonna print L to see if they are still the same object. And it's let's see, we don't actually want to print L. We'll say for X in L print X, and now they'll be stacked, and as you can see they're exactly the same, but we want to print the X dot X, the attribute X attribute, and see, okay, well, because we, yeah, like when you add an object to a list and then modify the attribute, and that's the cool thing about objects, is you can add them to a list, modify a part of the object via its attribute, and that change is reflected in the it's reflected in the list entry, even though before you change that attribute you appended it to that list. So now I have a much better understanding of how remove works and what exactly it means when an object is at a particular memory location, and what that means for using the remove method and all that. And it's not necessarily that the attribute is changed, it's simply that you called pickle. When you pickle an object and then you unpickle it, it becomes a different object, it seems. So it's boiled down to basically that. But first, one last thing I want to do is okay, here's what we'll do. Now we're gonna comment this entire part out, and we're gonna say, so now we just have, we don't need the send or receive list. Now we just have, or this. So now we just, we also don't need that, and we also don't need, okay, so now we have the class instance. We have L, which consists of C1. We change C1's X attribute to 7. We append to L C1 after it's been modified. So now we have two elements in L. They're both C1, but we modified C1 between the addition of the two objects. And then we iterate through L. We print out each object to determine that it's the same. But here's what we're going to do. Now we're going to say, which we don't actually need this right now. Well, I'll leave that. And we'll say L dot, I'm sorry, we'll say sought after object equals L at index 1, which is the second object, and then we're going to say L dot remove, and we're going to remove the sought after object. So well, I don't know if this is actually a way to tell. It won't actually, because they're both gonna have the same if we say, hold on, if we say sought after object dot ID equals 1 or 2, and then we print L at 0 dot ID, what would this print out? It still prints out 2. Okay, because those are the same objects. Yeah, so there's actually not a way. Okay, no, there is a way to test this. So what we would do is we say sought after object is L at index 1, and if we can call remove twice, then that means yeah, so now L should be empty because we were able to call L on remove on it 2 times. Even though those 2 objects well, they weren't actually different because like they're at the same location, so when I modified one, it modified the other. But now I know the means by which remove removes the object. It removes based on the memory index. So let's erase all of this because it's become a lot and it's kind of confusing. So what we're going to do is we're going to go all the way up here. We're going to leave the class and then the class instance. And now we're we don't need all those attributes, we just need 1 and 2. And now we'll say what's this line for when we dump it and then when we load it. So now we'll create another one and we'll call it loads, and now we'll get rid of all the rest of this. So there it goes, bye bye. Okay, and we can get rid of chicken and eggs and 3. We only need we really only need 1 attribute. It's not important. So now we have the C1 class instance, which is just 1 object. Now we're going to say cserialized1 equals pickle.dumps C1, but first we're going to print C1. So we create C1, then we print C1, then we serialize C1, and now we're going to we're actually going to call loads on C1 serialized 1 to see if that, like, okay, so we're creating a dump of C1, serializing it, and we're calling it serialized C1. So then we're going to grab serialized C1 and we're going to unserialize it using loads and assign that to C serialized 2. And I want to see what each object is as far as its memory index, memory ID or whatever you want to call that. Like, I don't know the word for it. So this will be C serialized 2. And now let's see, what does it return? Okay, so C1 prints is this, and then this is the serialized version, which makes sense because now it's serialized. So we actually don't want to print that because that one's going to be in bytecode, and we'll just print these 2 to see if they're the same. And as you can see, the C1 prior to being pickled is referenced as E20, but then after we, well, how about this? We'll do this even like cleaner. We'll say pickle.loads and then pickle.dumps on C1. So we're actually only dealing with C1. We're passing in C1, we're dumping it, and then we're serializing it, and then we're immediately deserializing it, and then we'll just call this C1 deserialized, and we're gonna print C1 deserialized, which is done like that. Okay, now it almost got me. I thought they were the same, but they're not. So this one is DC0, and then this one is DF0. So when you pickle an object, and then when you serialize an object and then deserialize it, it is no longer at the same memory location, and that makes sense because you're moving it. You're not moving it because C1 is still gonna be at that same location. So let's print C1 after, and as you can see, we have E20 for C1, E50 as C1 deserialized, and then E20. So when you serialize and then deserialize an object, it is not considered the same. And now, just to like verify what I already know, we'll say deserialized 1 is when we call all that on C1, and then C1 deserialized 2 is going to be the same exact thing called on C1 again, and now we're going to print C1 deserialized 1, and then print C1 deserialized 2, and we'll print C1 first. So we have C1 deserialized 1, C1 deserialized 2. So C1 is EE0, and then deserialized 1 is F10, deserialized 2 is 3C0. So that's exactly what we had expected, that those objects were going to be different, because now we know what determines that. So what we want to do now is to do the final test on what exactly happens in our code that we're testing for in this file. We're going to have a list, and we're going to we'll create the list up here. We don't need to print C1 anymore because we already know what that's going to print out. We create L, then we create C1 deserialized 1, C1 deserialized 2, and then we're going to say L.append, and we're going to append C1 deserialized 1, and then here we're going to append C1 deserialized C1 deserialized 2. Now we're going to print L and see that those two objects will actually do it differently. We'll say for X and L, and we're going to print X. So now we have at A330, A390, so they're two different objects. And then if we say L.remove, and okay, actually we have to say sought after object equals L at index 1, which should be 390, not 330. We're gonna then print sought after object, so we know just for sure. Then we'll hit remove, and we're gonna remove only the sought after object, so it shouldn't remove 330, it should remove 390, and it's gonna be different now. So it's 3C0 and then 420. That's each of them. And then the sought after object is 420, which is correct because it's index 1, the second object in the list. And then after we remove the sought after object, it correctly grabs the right object because they have different memory identifiers. It removes 420, which is the sought after object, and it leaves the first one. and even though the attributes of the object are completely the same, they still have a different signature. So if we were to call remove again for a sought after object, it would not be able to do that. It's going to throw an error because it's going to say X is not in the list. Okay, so now we know. Reminder that dot remove, we'll say list.remove to be more specific. List.remove removes the first instance of the object when a class instance this is the case, based on the memory location of the object, even if the adders, even if the two objects have the same adder vals, etc., as long as the two objects are two separate serialization deserialized objects, they are considered two different objects that exist at two separate memory locations. When you use remove, it will only remove the object at that memory location. TLDR. Okay, and then this we'll put on a different line actually. Okay, cool. So now I know. We'll put this in tested remove. We'll say tested list.remove methodology to determine whether or not data transfer modification code was bugged at line number, and this was at which line? This is at line 706. Okay, line 706, and then just in case that line number changes, we'll put current client dot receive object list dot remove current object. Okay, now that was really good. That was a really good test. That was really important to understand. I'm not really super familiar with remove. Like I said, I always use pop and stuff because pop is just like you can grab and then do something else with something after you pop it, but if you do remove on it, it's just gone. And in the scope of my game that I'm making, pop is just like much more useful since I'm not ever usually deleting things. I'm like grabbing a card and then moving it to a different location. So I will pop and then append, and they're all associated with each other with all kind of logic. So that was really important for me to understand and learn. And I'm going to take a little 5-minute break. Okay, I'm back. Alright, so we figured that out, and we verified that it would be that it should be fine. Because current object is the current client to receive object list at that particular index. And it's going to reference only that object. It's not going to reference whatever object is at that index at a later point in time. And then that's just one little minor thing I want to test just to be absolutely sure of, because anything that I'm not absolutely sure about is good to test beforehand. So we'll have a list, and the list will be 1, 2, 3, 4, 5, and then we'll say x equals L at index 1, and now we're gonna print x, and then we're gonna say L dot remove x, and then we're gonna print x again. Oops, let's go down here. So now it was at index 1, x was assigned to L at index 1, which is 2, and then so we print x, which prints out 2, and then we do L dot remove x, and so it removes 2, and even after we have removed x from L, since x was originally assigned to the object at L at index 1, which was 2, after being removed from L, so like you could say if it were to be dynamic, then x after we removed x from L would now equal 3, but that's not how it works, and that's what we would expect, that's what we want. So it's good that this equals 2. Reminder that if you assign a var to an object at a particular index of a list and then remove that object from the list, the var will still reference the original object and not the new object at that list's index. that makes sense. I think that'll make sense. Okay, so we're good there as well. Let me smash this water. Alright, now we can put that we reviewed and verify that this section is correct. So we'll go back to that line, which is right here. And I'll put reviewed it, put reviewed the logic associate the methodology of .remove to verify this line is properly written and will function as intended without bugs. Since remove finds the first match and each object is identified by method, or not by method, by remove via the memory location ID, it will never mistake one current object for another object in the receive object list. Thoroughly tested this in test reminders.py at lines and I forgot to put the date. That's good to have all that just in case I wanted to look at it in the future. So right here, 24. Okay. And the line, that's 3297 to 3330. So 3297 to 3330. Alright. So now we can remove that from things to do. Alright, cool. So that took a long time to do that, but now we know for sure. So what we can do is move to the next section, which is what? Yeah.
Just said, I haven't talked to him in a while, but it just dawned on Dino.
Oh yeah.
He's got a I just sent him a asked our friend requested him on Facebook, and sent him a message. I didn't tell him anything about what's going on. I just asked him how he was doing.
Yeah.
Said maybe I see your brother from time to time in the store. Always ask about you. Hope you're doing good. Maybe I can come visit soon. And when he messages me back, because he's got an empty bedroom at his house.
Yeah.
That's where he was letting Aaron stay.
Yeah, that'll be perfect. And I'll just say that you went to Aaron's.
Yeah, she don't need to know where.
Yeah, and then once I get that cash, once she fixes it, bam.
You can't tell her where to Aaron. Because if she comes up to the store,
Oh yeah. Okay, I'll just be honest and say you're going to stay with Dina.
Yeah.
And then as soon as I get it back, I'll just come pick you up the next day. And once I got that money, everything else we can fight about. But that fucking money that she owes me, that's something. That's a big, huge deal. Yeah. So.
All right, I'm waiting to hear back from him. I'll keep you posted.
Okay. So this is good. We finished this. This is all done. So I think this is it, right? Okay, so we reviewed everything multiple times. I feel like I'm forgetting something though. But let's go ahead and let's see. Go all the way back up here. Just go all the way to the beginning and just scroll through. Okay, so this is the beginning of the data transfer modification, and then it ends. So we receive, we sign other, receive string, we run our log, then we append the inc data to the receive object list. We iterate through the timestamp list. We append to the timestamp order list. Oh, no, that's right. Yeah, I thought I saw a bug, but it's just out of sight. Okay, now we sort the order list based on the timestamp. Then we grab the earliest timestamp. Then we check the current time against the earliest timestamp. We already double triple check that. Apply list is equal to a list of the current client order list at index 0, and then we iterate through the order list from index 1 onward because we already have the first element assigned to the apply list. And then if the current time is minus the timestamp is greater than or equal to 4, meaning it's been 4 seconds since the passage, since the reception of that data, then we would append this tuple to the apply list, the tuple being the actual order list entry, and then else once we come across one that doesn't apply to it, we will break out of it. And then make sure you review the section below here up until line 658 after opening the what does this say? Make sure you review the section below here up until line 658 after implementing the apply list, replacing the order list copy change. So this was concerning me implementing the apply list in the context of it replacing the order list copy. Okay, so here we have the apply list. So for to in apply list copy, okay, we say current object equals current client I receive object list toop2. Apply list copy. Object equals current client I receive object list. So we don't actually need the apply list to be copied because we're not popping from it. We end up popping from the, or removing from the order list. Iterating through the apply list copy. Yeah, so we don't need to make a copy here because we're not modifying it. We don't ever pop from the apply list. And since we would be going from the beginning to the end of the order list, and since this would be the order list at index 0 for the first iteration, and then so that's what we're at the end of this, we would delete from the order list at index 0, okay, and then we would the order list at index 1 would then become the order list at index 0, so that the next iteration through the apply list, when we call this again, would properly, it would delete the proper object. Okay, yeah, so I think that's true. I think that's right. Okay, and yeah, so I think everything looks really good there, I think, anyway. And we're okay, so right here for this comment, iterating through a copy, yeah, we don't actually use a copy anymore. Iterates through the apply list to apply to check data in order of timestamp. Okay, so that's And we reviewed the section below here after implementing the apply list, releasing the list copy change. That's what we just did. So yeah, that's made one more final pass reviewing the apply what is it called? Is this for send or receive? This is for send? This is for receive. Receive section. Made one more final pass reviewing the client files, data transfer modifications, receive section. Okay, so that is it for this. So now we can move on to the next thing and things to do, which we finished the rework of line 600 to 660 to ensure data transfer is concerned. Server line 600 to reject timestamp list. I still don't know what that means. Review all work after completion. I'll just leave that. Review caution. No, we'll do that later. Finish implementing data transfer modification. So what's the next step in that? So we did server. Let's see. We'll put already done, and we'll put client by send section, and then serve by what send section. Yeah, I think that's right. So the send is yeah, okay, so that is good. Now as far as the receive, I don't think we did the receive section for server. Yeah, I don't see that we did that. So we would have to add in the receive section for server. And how would we do that? Yeah, okay, so yeah, we would implement the, we would unpickle it. Oh, see, did we do that correctly? And let's see. So we have, yeah, we have pickled it first before we, oh wait, no, that's a different part. Right here, ink data receive. Okay, yeah, so the deserialization is implicit, I think, in network receive. Yeah, we actually unpickle it through network, so that's already done. So that's verified. So yeah, we would have to. What is this called? Why do we change the name here? Why do we do that? Receive data unpickled, and then we say pickle.loads receive data. Why wouldn't we just call this ink data? Like, is there a reason to not just call this ink data? Okay, I see what I want to do here, and I'm going to do that at a later time because I actually want to reverse the names. 1, 2, 3, 4, 5, and then this is 6. We'll put below section comment added 3, 12, 24. Reviewed this section and realized that the names should be swapped. Inc data should be the data that is incoming, and then receive or received data should be the name given to the data after deserialization. Also, I don't think I need to even have the receive data unpickled, and I could just assign that directly to received data namespace from 3 lines to 2. A 33% reduction. But for now, I'll just leave it, because I'm changing so much as it is before I'm able to test again. That is very dangerous. I don't want to change anything unless I am absolutely certain, like, that it's correct. And also, even if I was absolutely certain, I still could be wrong, so I wouldn't want to change it. And really, I don't want to change anything unless it's something that has to be changed, having to do with the data transfer modifications. So we'll copy this right here, and let's see. So this would be the, let's say, the start of data transfer modification. And then the end of the, we'll say, and this is for receive. And then the end would be down here. So let me say end of data transfer modification section, or we'll just say receive section. Start of data transfer modification receive section, end of data transfer modification receive section. Okay. So yeah, that's a good place to start for it. So we'll do that next, I think. We did SurPy's send section. So actually we'll just put section main sections to be completed, and we'll put send section completed, and then this one will be completed, and then section receive section, I don't know, I can't remember if we finished that. And then SurPy's send section, SurPy send, receive, and we did the SIRPy send section. Yes, that's done. And then the client pi's receive send section is also done. No, wrong. Where is it? Oh, so we did, we added the DirtCheck timestamp list append line. Okay, so we actually did do the client's send section and the client's receive section, because we just finished the receive section, isn't that right? Yeah, end of data transfer. 2, 3, 4, 5, 6. End of data transfer modification receive section. Yeah, I think that's right. And I like the space being between them actually. Yeah, that's better. So this up here. Let's start. Change it to start data notification receive section. Where is that last year right here? Sort the timestamp order list. Yeah, we did that. Okay, that's needs to be removed. That was one couple lines we forgot to delete, so that's better. Alright, so now we're going back to server. So yeah, send section for client is done, and receive section for client is done. Server's send section is completed, so now we have to do send server's receive section. So let's actually close, well, we don't have to close client. So this is server, so make sure I'm in the wrong, the right place. I'm getting a little bit tired. I really don't want to make a second coffee, but I might have to get up and like go do something outside to get my energy back up. Before send, so send is done, and then receive is where? Right here. Okay, so we're gonna put 232 so I know. Starts at line number 232. Ends at line 247. Well, that's not going to be 247 once we implement. So, alright, so what do we need to do here? Well, first of all, we can fix this section, because this is actually going to be replaced with the other format. So I'm gonna copy this entire line section rather from client, and it should be virtually the same. So we're gonna paste it over here. We have to be careful though. It assigns the current or other receiver based on equality with current client ID. The logging printout usage, and then link data ID is equal to current client ID, current or other receive strings. Current and then link data ID is not equal to current client ID. Current or other receive string equals other, and then link data date. So yeah, this references ink data, which is fine because we have ink data. Now this is for server side and we're receiving, so we compare to see if the ink data ID is equal to the current client ID. Now is that correct terminology from server side though? Yeah, so we do. Yeah, we have, this is in the threaded client, so this is for the each client. Yeah, so this is good. This is how we want it. Ink data ID is equal to current client ID. Current or other receive string equals current. If ink data ID is not equal to current client ID, current other. Okay. And then ink data adder dig id.c play ad change where game deck and then locations, and then for ink data attribute string in ink data adder dig custom language respect print func blah 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 blah. The line number, current or other receive string, client receive data. Yeah, that's all good. Okay, but this is actually not client by, this is now ser by. And then we'll put low section comment added 24 being replaced by above, leaving until 100% sure replacement is valid. Alright. Match our divs for the end of the section, and this as well is going to be replaced, but for now we'll just comment it out. Okay, and now we can go ahead and actually I will put being replaced by ... and the end of the div right here. Okay, now we want to replace the dirt check call, which this is basically just another, like, we're basically just going to be copy and pasting as far as I can tell. So let's put side by side. We'll actually just put client over here, side by side, so we can look at them next to each other. Alright. So this is for the receive. There's the beginning of it. Okay, start of data transfer modification receive section. Alright. So we did that already. Now we would now here's something that I want to make sure about. Okay, so whenever we send an object, a client, over the network, doesn't that mean that we are going to when we send an object over the network, won't that mean that the receive object list would be sent along with it? Now that's an issue we'd have to resolve, because we don't want to ever send with a populated receive object list. Let's put ensure that receive object list will be transferred along with the client object is empty whenever it is sent. We would receive pickling serialization errors or other data transfer errors associated with this. Plus, we don't want to transmit this data at all. Because it consumes extra computation power and memory. Right. I'm getting really tired. I think I'm gonna go for just a little bit more. I'm gonna try to finish this section in server and then call it quits. So that's something we need to take care of, but I'm not gonna worry about that right now. We'll do that next time. So devlog, we'll put begin implementation of data transfer modification for serve-pies receive section. Put and finished. Alright, so back to the client, and so basically we're just going to paste this over. Our client receive object list append ink data. So whenever this gets sent, so essentially how do we, I'll worry about that another time. I'm not going to worry about the receive object list population issue right now. I'm just going to worry about this. So we have the receive object list append data for 2 pending data times list. So this part is fine. The only thing is the concern about the receive object list. So we'll just paste line for line. So we can copy this one, and this would actually be, we put replaced by above. So, okay, now for dir check, being replaced by below. So, replaced by below. Okay, yeah. So that we'll match that template, and we'll say it's being replaced by below section, leaving until 100% valid replacement. 100% sure replacement is valid. Alright, so we'll paste that line right here. And current clients receive object list. We append the incoming data to it. So we have the inc data. We assign this. We print out our log, and we append the inc data to the receive object list. Now we begin iteration through the inc data's timestamp list, which should be fine. And then we append to the order list. That makes sense. And also I'm realizing also ensure that the order list, etc., remains properly populated and that no data is lost or doubled, etc. Yeah, that's kind of vague, but I know what I mean. So over here, we're gonna copy these two lines from 624. Okay, we already did that actually. Pending that. Alright, now we would say for above line reference, we do want to copy that over as well. Okay, and alright, now we have the sorting of the order list. So we say for 2, then current client order list append, then non-indented order list sorting with the comment. Now we're at 628 and 629, which is where we assign the earliest timestamp. Yeah, so I just feel like this is gonna be fine doing it like this. Okay. Then these next two lines. Alright. And then we want to put all of this little section right here. Okay. Then in this indented section, we'll just, I'll copy a much bigger section now. I'll just go all the way down to the end from we're at this line, indentation. We're gonna go all the way. This is all the way to the end of the. This is all the rest of it. From else break, then it's non-indented, but it's still indented within if time. So we still. So yeah, if time, and then it goes all the way down to else break, and then at the same indentation of this, we have for tube and so let's go verify it's correctly indented. Okay, for tube and apply list, and yeah, so we literally just copied it or all the entire section. It gets all the way down to right there, indents 1. And that's the end of it, and then it says end of data receive section. Okay. Alright. Just to verify this is on the correct indentation as well for the start of the section. Yep, start to transfer modification receive section. Alright, so that's good. And I'm gonna put right here below entire data transfer modification. How do I call it that? Data transfer. Well, okay, yeah, because it's modifying the data transfer framework. Below entire data transfer modification. Added 3.12.24. Copied and pasted the entire thing from client.py. I did not review it, but I believe everything should be valid. We'll put 6 stopped here. Alright, so we're gonna stop there. So we basically just copy and pasted everything over from yeah, we basically just copied everything over, and yeah, we don't call draw window main on this side. So we get the ink data. We'll just review it real quick. We're not going to do a thorough review. We assign cur client. We create our log. We append to the receive object list. Iterate through the timestamp list. We append to the order list. We sort the order list. We get the earliest timestamp. We check the time for the apply list. Say for tube in order list, excluding the first one. We append to the apply list all the pertinent things. Then we break out of the for loop. Once we find one that doesn't match, then we say for tube in apply list. And then we proceed to go ahead and assign all of our args for the actual dirt check. But we don't. Where do we apply the? Okay, right here. So this is the actual dirt check, and then we delete from the order list, and we check to see if we want to delete from the receive object list. Yeah, so everything looks good, I think. But you know, when you copy and paste that much stuff, there are bound to be issues with it. It might not directly reflect from one file to the other. Let me just make sure, since I'm in server.py, I'm going to go to the beginning of this little section right here, and we're going to put this is client server.py. I just want to make sure we didn't put client.py, which we didn't. It is right. Yeah, so that's good. Alright, so we actually finished it, but finished it in the ghetto sense that we just pasted it, but it should be fine. We do the same thing with dirt check. We actually should make this a function, and I'll put that. We'll put convert the large section, the large data transfer modification sections from used in both py insert py's receive sections to a function to reduce lines and bug possibility of bugs, and this will put completed, or we'll just put copied and pasted from py needs thorough review. Stopped here. Alright, and now we can put that in the devlog that we began and finished implementation of data receive section. Actually, we simply copied and pasted from client py's associated receive sections since they are virtually the same. Did not review the copy and paste to ensure proper logic transfers one file to the other. Needs to be done. Okay, and I did put that on things to do. Yeah, needs thorough review stopped here. Alright, so that's good. We're good. We're gonna go ahead and quit for today because I'm tired. I just don't have it in me anymore to do this. So 10:45 to 2:45, so that's 4 hours. I did pretty good. I only took a very small break. I took like one 5-minute break and then like a 10-minute break. So in those 4 hours, I think I took about 15, maybe 20 minutes max, which is good for me. So we save all these files. Everything auto saves. We can go ahead and close this out. We can leave server open. Close client. And now we're gonna cd back to the parent directory, which is capital C Canasta. We're gonna get our branch, which is secondary. We're gonna go ahead and get add, which adds everything. We're gonna get commit with our message. Our message is gonna be a copy of our devlog. So something's wrong here. That's why it's not the right color. At least I think that's the issue. Saw some red text. What's up with this? Why is it doing that? Uh-oh. Something is... Okay, that's the problem. Why can't you just click right there? Okay. Alright. Let us... What is it? Okay, for whatever reason it will not. Let's try this again. Okay. Okay, so I guess it was because it was out of view. So now I know that when it's out of view of this terminal window, which you can collapse and expand as needed, that it has to be expanded all the way for you to be able to scroll back past what is viewable without it like throwing a error and just recirculating through that the visible section. Alright, so now we do git commit. 205 files changed. 202 insertions and 32 deletions. So we added 202 lines and we deleted 32. That's pretty good, even though like half of that was copy and paste insertion into server. So it's more like 101. That's still pretty good though. So now we'll do git branch just to triple check. Yeah, we're on secondary, so now we're going to do git push canasta secondary. And remember, we're not going to be working with master because master currently is the last stable version of the game prior to this data transfer modification. So we don't want to merge master with secondary until we have verified and that this implementation works and that we're able to debug it and all that and get it back stable, and then once it's stable on secondary branch we can transfer it over to master branch and then keep on going. Alright, so have a